Now, let's move on to the investigation section of this chapter. According to specification number 6, we are required to investigate and explain the effect of physical activity on heart rate. So, let's explore how physical activity influences heart rate and examine the changes that take place during exercise. So now, we are going to investigate the effect of physical activity on heart rate, and the main objective of this investigation is to see how exercise influences both the heart rate and the breathing rate of individuals. We begin by observing the resting state. At this stage, we check the participant's pulse and breathing rate before any activity. This gives us a baseline to compare the changes that occur during and after exercise. Next comes the activity phase. Here, participants perform exercises such as jumping jacks or running for about 5 minutes. Immediately after the activity, we measure the pulse and breathing rate again. As expected, both increase due to the increased demand for oxygen and energy. For example, the pulse might rise to around 140 beats per minute, and the breathing rate may increase to about 30 breaths per minute. Finally, we move to the recovery phase. After resting for 5 minutes, we check the pulse and breathing rate once more. Usually, the heart rate returns closer to the resting value, around 70 beats per minute, and the breathing rate decreases to roughly 16 breaths per minute. By following this procedure, we can clearly observe how physical activity impacts heart and breathing rates, and how the body recovers after exercise. Now, let's discuss the principle behind this investigation. When we engage in physical activity, our muscles require more oxygen and nutrients to keep working efficiently. To meet this increased demand, both the heart rate and breathing rate rise, ensuring that oxygen is delivered to the muscles and waste products, such as carbon dioxide, are removed. Even after exercise stops, the heart continues to beat faster for a period of time. This is because the body needs to repay the oxygen debt created during intense activity, particularly from anaerobic respiration. Additionally, a faster heart rate helps break down lactic acid that has accumulated in the muscles during exercise, aiding recovery. For this investigation, we will need a few simple materials: a stopwatch or timer to measure the duration of activity, a method to check the pulse, either using fingers on the radial artery at the wrist or the carotid artery in the neck, and a method to count the breathing rate. Finally, we need pen and paper, or a computer, to record our observations and results. This setup allows us to observe and record the changes in heart and breathing rates clearly, providing a practical demonstration of how the body responds to physical activity. Now, let's go over the procedure for this investigation. We begin by measuring and recording the resting heart rate. This is done by taking the pulse, either at the wrist or neck, and noting the number of beats per minute. Next, we measure and record the resting breathing rate. To do this, we count the number of complete breaths in 1 minute, where one breath consists of one inhalation and one exhalation. This gives us a baseline for comparison with post-exercise values. After recording the resting measurements, the participant performs a chosen physical activity, such as running, jumping, or cycling, for a set duration of time. Immediately following the exercise, we measure and record both the heart rate and breathing rate again. Once the activity is complete, the participant should be allowed to rest until their heart rate and breathing rate return to the resting levels before performing any further exercises. This ensures the accuracy of subsequent measurements. If necessary, we can repeat the measurements to confirm reliability. The results can then be plotted on a bar chart, which makes it easier to compare the heart and breathing rates at different stages: resting, immediately after activity, and during recovery. It is also important to ensure that the time period over which the heart rate and breathing rate are measured is consistent for all readings, so that the data is accurate and comparable. When we come to the observations from this investigation, we notice that both the heart rate and breathing rate increase during physical activity. This is the body's natural response to meet the higher demand for oxygen and nutrients in the working muscles. Even after the exercise has stopped, the heart rate does not immediately return to the resting level. Instead, it remains elevated for a period of time before gradually settling back to the normal resting rate. This shows how the body continues to work to recover from the activity. Looking at the results, we can conclude that increased physical activity directly leads to an increase in both heart rate and breathing rate. The heart keeps beating faster after exercise to supply the muscles with extra oxygen, remove waste products like carbon dioxide, and repay the oxygen debt created during intense activity. This clearly demonstrates the close relationship between physical activity and cardiovascular response, highlighting how efficiently the body adapts to increased demands. Finally, we come to the conclusion of our investigation on the effect of physical activity on heart rate. From our observations, it is clear that physical activity causes both the heart rate and breathing rate to increase. This happens because the working muscles require more oxygen and nutrients, and the body needs to remove waste products efficiently. After exercise, the heart rate does not immediately return to normal. Instead, it remains elevated for a while to repay the oxygen debt and help break down lactic acid that has built up during anaerobic respiration. Gradually, the heart rate and breathing rate return to resting levels as the body recovers. We can also see this pattern illustrated in a graph. During physical activity or exercise, the heart rate increases, and this increase is generally more pronounced in individuals who are less fit compared to those who are physically fit. Fit individuals tend to have a more controlled and efficient cardiovascular response. On this graph, the key shows unfit with red and fit with green, with heart rate plotted over time from the start of exercise to when it stops. This visual clearly demonstrates how exercise impacts heart activity and highlights the differences in heart response between fit and unfit individuals.